Have you ever thought about learning to code, but then you hear there are hundreds of different programming languages, and it just sounds completely overwhelming? Like you have to become fluent in a totally new language every single time. Well, what if I told you that's not really how it works at all?
I mean, look at this number. Some people say there are around 700 programming languages out there. 700! It's easy to see that and think, nope, that's an impossible mountain to climb. But here's the secret, it's not. They aren't all these unique, separate worlds you have to conquer.
Because here's the real deal. Learning to code isn't about memorizing 700 different sets of vocabulary. It's actually about learning one core set of ideas, a kind of universal grammar that almost all of them share. Once you get that grammar down, picking up a new language is more like learning a new dialect, not starting over from scratch.
Okay, so let's dive into what this universal grammar actually is. We're going to break down the 3 fundamental building blocks that you'll find in pretty much every programming language, from the simplest script you can write to the most complicated app on your phone.
First up, we have variables. The easiest way to think about these is as the nouns of your code. They're just little labeled containers you create to hold on to information. Maybe it's a number, maybe it's some text, or maybe it's a simple true or false.
So, if variables are the nouns, then functions are the verbs. They're the action words. A function is basically a named chunk of code that does a specific job. You hand it a variable, and it performs an action with it. Simple as that.
And finally, you need some rules to tie it all together. That's where control structures come in. They're the traffic cops of your code, directing the flow. They let your program make decisions or repeat actions over and over, which is what makes code so powerful.
And what's awesome is how natural these rules feel. The 2 big ones are conditionals and loops. A conditional is just an if-then statement. If it's raining, then take an umbrella. A loop just repeats something. For each item on my shopping list, do put it in the cart. See? You already think this way. This is the logic that runs the world.
So, you've got the grammar, nouns, verbs, and rules. Now let's see how this actually looks in the real world. We'll take a peek at 3 different languages, or as we should really think of them, 3 different dialects of code.
All right, here are our 3 contenders: Bash, Python, and MATLAB. Bash is a workhorse, perfect for automating tasks right from the command line. Python is like this Swiss Army knife, incredibly versatile, used for just about everything these days, especially data science. And MATLAB is the specialist, a math whiz built for heavy-duty engineering and research. They each have their own strengths, but they're all built on those same core ideas we just talked about.
Let's prove it with the most classic program of all time, just getting the words "Hello World" to show up on the screen. In Bash, the verb, or our function, is echo. You tell it what noun to act on, in this case the text "Hello World," and boom, it does it.
Okay, now let's jump over to Python. See the pattern? The goal is exactly the same. The noun, hello world, is identical. The only thing that's different is the specific dialect for the verb. In Python, it's print.
And finally, let's look at MATLAB. Again, same concept, just a slightly different word for the verb, disp, which is just short for display. This one little example shows you everything. Once you understand the idea of a function that displays text, learning whether it's called echo, print, or disp is just a tiny, easy detail.
All right, you get the concepts, you've seen how they look in different languages, but what do you actually use to write the code? Well, just like a woodworker has a toolbox, every programmer has a set of digital tools that make life so much easier.
So first, you need a place to actually write your code. You've basically got 2 kinds of options here. There are code editors like VS Code, which are like flexible, all-purpose workshops that can handle tons of different languages. Then you have IDEs, which stands for Integrated Development Environment. Think of these as a specialized, all-in-one workshop built for a single language, with every tool you could possibly need, like MATLAB's environment.
And then there's this other amazing tool, especially if you're just starting out, called the Jupyter Notebook. It's not just a blank page for code. It's an interactive document where you can mix live, runnable code with your own notes, images, and charts. It's a fantastic way to experiment and really tell a story with your code.
Now, as you start using more tools and libraries, you are, I promise you, going to run into a very famous, very frustrating problem that coders lovingly call dependency hell. This is when you install one thing and it suddenly breaks another thing because they both need different versions of the same shared code. It's a nightmare.
So how do you escape this mess? With a brilliant tool called a package manager. It lets you create a totally isolated sandbox for each of your projects.
You just step inside your project sandbox, install exactly the tools you need for that one project, and it can't mess with anything else on your computer. It is an absolute lifesaver.
A really popular package manager, especially for Python, is Conda, and it comes in two main flavors. You've got Anaconda, which is the treasure trove. It's a huge download, but comes with pretty much every data science tool you could ever want, all pre-installed. Then there's Miniconda, the minimalist. It's a tiny download that just gives you the basic tool, and then you install only what you need when you need it.
Wow, okay. We have covered a ton of ground here, right? We've gone from the really big, abstract ideas about what programming is all the way down to the nitty-gritty tools you'll be using every day. Let's just pull it all together.
It really boils down to this. At the core, all programming is built on a handful of universal concepts. The hundreds of different languages out there are just specific dialects for expressing those same concepts. And to bring it all to life, you have these powerful tools that make the entire process possible.
So you see, learning the code isn't about climbing 700 different mountains. It's about learning to read one single map that can guide you through any of them. You have that map now. The only question left is, where are you going to go first?